Hello everybody, this is Mr. Bowen. So today we're going to be looking at use of standard form that might be helpful. So we talked previously about standard form, okay, and specifically it looks like ax plus by equals c. And we already went through the requirements, what a, b, and c have to be into, so we're not going to get into that in this one. But specifically, we're going to look at how to find the slope from standard form, and also we are going to just make sure we remember how to find parallel and perpendicular slopes once we do have that. That second part is not really changing, but it's always good to review. So you can, if you have numbers here, or even without numbers, solve for y and turn this into slope-intercept form and then find the slope that way. But you don't have to. There's actually a faster way to do this, and it's pretty straightforward, but it's not always the easiest thing to remember because it's just kind of a fact. It's not a process or something that you can kind of remember parts of it and put the rest of it together. So you can always go to slope-intercept form if you don't remember how to do this, but it is helpful. So if you're trying to find the slope from standard form, it basically breaks down to negative a over b. So if you have numbers here, you just have to plug your numbers in and see what you get. So let's say if I have something like 3x plus 6y equals 5, or something like that. If I just want to find the slope, all I need is to identify a and b and plug them in. And just be careful with your signs here when you're plugging those in. So these are both positive, so it should be pretty straightforward on this example, but we'll see what to do with some negatives here in a second. So a is 3 and b is 6. So here, negative a is negative 3 divided by b, which is 6. I want to make sure I reduce this, so I end up with a slope of negative 1/2. Okay. But what if I do have some negatives in here? I don't have to worry about a being negative, because remember, a has to be positive, but I might have something like 4x minus, let's go with 10y equals 12 or something like that. Same idea, just be careful because the negative sign needs to come with 10. So right now I have negative a, so negative 4 divided by b, which is negative 10. When I reduce that, I have to clean up those negatives as well. So I have two negatives, which divide out to be a positive 1. So this entire thing reduces to a slope of 2/5, positive 2/5. So it takes a little bit of getting used to, but after you get used to it, and if you remember that formula, it's pretty fast and pretty straightforward. Now, I did say we're going to review a little bit about parallel and perpendicular slopes. So remember, a parallel slope has to match exactly, and a perpendicular slope has to be a negative or opposite reciprocal. Okay. So let's run through the two that I have here. My parallel slope, which I'm going to use some geometry notation here. So there's two lines together means parallel. So a parallel slope for this one would just stay negative 1/2. And perpendicular slope, which kind of looks like it's upside down t, is going to be the negative reciprocal. So right now it's already negative 1/2, so I need to swap that and make it positive. And then I'm going to flip my fraction. So the reciprocal would be 2/1, but remember, you don't have to write that over 1, so it's just 2. Okay. What about down here? So my parallel slope, once again, is exactly the same. That's the nice and easy one. My perpendicular slope is positive, 2/5 positive right now, so I want to make it negative and then flip it, so it'd be instead of 2/5, it's 5/2. This one doesn't reduce at all, so you would just leave it there. Okay, so quick review on parallel and perpendicular, and then how to find slope directly from standard form without solving it to slope-intercept.